This is the second video for section 13-3 for accelerated geometry on adding and subtracting rational expressions. So our vocabulary word in this video is a complex fraction, which means that it contains one or more fractions in its numerator, its denominator, or both. So for example, if you have 2/5, which is a fraction, divided by 1/3, which is another fraction, then that's a complex fraction. Or you could just have x divided by the fraction 2x plus 1 over 3, and that would be a complex fraction. You could also have x plus 5 over x minus 2, so there's one fraction, divided by the other fraction of x minus 2 over x plus 3. Please remember that a fraction bar is the same as division, so a complex fraction is really just a complicated way of writing a division problem with rational expressions. So in our first example, it says simplify and assume that all expressions are defined. That means we don't have to worry about when it's undefined. So if you remember that when you're taking a fraction divided by a fraction, that you have keep, change, flip. That means to keep the top exactly as you see it, change division to multiplication, and flip the denominator. So instead of x minus 3 over x plus 5, you're now going to have x plus 5 over x minus 3. Once you have this, you're going to look and see if anything cancels out. Is there something up top that cancels with what's on the bottom? And the answer is no. So then we have, when you multiply fractions, you multiply straight across. And then this would be our answer. Now, say this was a multiple choice and this was not our answer, then we would probably need to go through and FOIL the top. So if I FOIL the top, that's going to give me x squared plus 7x plus 10. And if I FOIL the bottom, that would give me x squared minus 4x plus 3. And then that would be another choice that you could see on a multiple choice test. Example 2, if you notice up top we have addition before we do the division. So what we need to do first is simplify what's happening up here on the top. So off to the side we have 3 over x plus x over 2. So our common denominator here is going to be 2x. So what do I need to multiply the first one by in order to get 2x here? And that would be 2. So that's really a 6 up top. The second one has to, in order for 2 to become 2x, you have to multiply by x. So x times x gives me x squared. And then if I combine these, that's just going to be x squared plus 6 over 2x. So what I really have on this problem is x squared plus 6 over 2x divided by x minus 1 over x. So we're going to use the keep, change, flip, if you notice that on the bottom there's an x and on the top there's an x, so I can go ahead, since there's an x on the bottom and an x on the top, I can go ahead and cancel those two x's out. So up top I just have x squared plus 6. On the bottom, I have 2 times x squared. I'm sorry, this should be x minus 1. So that's going to be 2 times x minus 1. So then if we just distribute the 2 on the bottom, we would have x squared plus 6x over 2x minus 2. Now, what I would like you to do is to pause the video and try number 3 for yourself, and then come back and look at what I did versus what you did. Okay, so on example 3, hopefully you kept the first fraction the same, so x plus 1 over x squared minus 1, change division to multiplication, and then flip the denominator, so that's going to be x minus 1 over x. Then if you notice, this first denominator is factorable. It's the difference of squares. So if we factor this, this is really x plus 1 times x minus 1. Why do we need to factor it? Because if you notice, there's an x plus 1 up top and an x plus 1 on the bottom, so they cancel. There's an x minus 1 up top and an x minus 1 on the bottom, so they cancel. And when everything cancels up top, you're really left with a 1. So your answer would be a 1 up top for your numerator and an x on the bottom for your denominator. So final answer is 1 over x. Pause the video and give number 4 a try. Number 4 is very similar to number 2. Okay, so on example 4, first thing you need to do is to simplify your numerator because you have addition of fractions here. So your common denominator would be 2x, which means you need to multiply the first fraction. To change x to 2x, you had to multiply by 2 on the bottom, which means you need to multiply the 2 on the top, which really gives you 2 over 2x. And then you're adding 1 over 2x. You didn't have to change anything to this one because the numerator was already a 2x. So then 2 plus 1 left me with 3. The top is really 3 divided by 2x. And then I can use my keep, change, flip. So I kept the top the same, changed division to multiplication, and flipped the denominator. So now it's x minus 2 over x plus 4. And if you notice, nothing cancels. So then we just multiply straight across. And you are left with 3x minus 6 over 2x squared plus 8x. Let's look at some application problems. It says a hiker averages 1.4 miles per hour when hiking downhill on a mountain trail and 0.8 miles per hour on a return trip when when walking uphill. What is the hiker's average speed for the entire trip? In case you don't remember, speed is just distance divided by time. So first thing we got to figure out is the distance. Well, your total distance was 2 trips, and we don't know how long the trail was. So it's 1 trip plus 1 trip, which comes out to be 2 times whatever the length of that trail is. Then we have our time. Which is going to be the distance of the first trip divided by his speed, because if you manipulate this equation, you get that t equals distance over speed. And his speed on the first going downhill is 1.4 plus the distance on the return, which was 0.8. So the first thing we need to do is simplify this rational expression. So a common denominator, easiest way to do it on these type of problems is just to multiply these two numbers. So off to the side, if you do 1.4 times 0.8, you're going to get 1.12. So then for this first fraction, if I change that to 1.12, the top has to be multiplied by 0.8. So that's going to give me 0.8b. Plus, to change the second one to 1.2 on the bottom, we multiplied by 1.4. So up top, if I multiply by 1.4, that's going to give me 1.4d. Now we can just add 0.8 and 1.4. We get 2.2d over 1.12. Then if we go back to our main speed formula, we have that speed equals the distance was 2d divided by the time, which was 2.2D, divided by 1.12. And then now we know to keep the top the same, so the top is really 2D over 1, if you need to put that there, times, flip the denominator, so if you notice, you have a D up top and a D on the bottom, so they're going to cancel. So all I really need to do in my calculator is 2 times 1.12, take that answer and divide by 2.2 to get 1.02 miles per hour. Okay, example 6 is just like example 5, so I want you to pause it and give example 6 a try for yourself. Okay, for example 6, your final answer should come out to be 42.35 miles per hour. Now, what did we do to get there? So speed is still distance over time. He still made 2 trips of the same route. So your total distance is just twice whatever the length of the route is. Your time would be the distance of the first on the way to school divided by the time or the speed that it took to go to school, which was 40 miles per hour, plus the return trip home over the speed on the return trip home, which was 45 miles per hour. Then off to the side, I multiplied 40 times 45 and got 1800, so that was my common denominator. So since I had to multiply this by 45 in order to get 1800, that means I had to multiply this by 45 to get 45D over 1800. The second one, 45 had to be multiplied by 40 to get 1800, so D times 40 gives me 40D over 1800. 45 and 40 makes 85D over 1800. So then I went back to my speed formula. The distance was 2D divided by the speed of 85D over 1800. Kept the top the same, changed division to multiplication, and flipped the denominator. The D's cancel, so I'm just left with 2 times 1800 divided by 85, which gives me that final answer.